Welcome back. Let's look at another problem, specifically a constrained motion problem. So, collars A and B slide along the fixed rods and are connected by a rigid bar of length c. Write an expression for the velocity of collar B, which we're going to call B dot, in terms of the following: A, B, C, theta, A dot, and C dot. Note that A is positive to the right. And then finally, it's asking us to simplify our expression for B dot if given the specific theta value of 120 degrees. Okay, so if we're looking at this problem, we know that we're going to have some kind of equation that is going to relate all of our geometrical parameters. So you can imagine that if, here, I'll move this box up, that if we have collar A and we're going to push it to the right, it's going to pull collar B down, and vice versa. If I push collar B up, it's going to pull collar A to the left because they are constrained by the rigid bar C. And so because they're constrained like that, we can use one of the triangle laws that we know, specifically the law of cosines, to relate our problem of interest. So I'll just write out the law of cosines real quick, and then we'll see what we can do. So we have a value for theta. We see that alpha isn't really necessary in this problem. And so we'll go ahead and write the law of cosine. So we have c squared is equal to a squared plus b squared minus 2ab cosine theta. But we're interested in the velocity. Specifically, we want to get b dot. So if we go ahead and take our derivatives of this entire term, we can get a new expression. And so we'll go ahead and do that. Following the chain rule, we have 2c dot is equal to 2a dot plus 2b dot. And now we have this minus term over here. And so while it might be apparent that theta does not depend on time, I'm going to write it as I will write it as if it does, and then we will see some terms cancel later on. So I'll pull the 2 out now, so minus 2, and then the entire quantity will go right in order. We have a dot b cosine theta plus a b dot cosine theta plus a b, take the derivative of cosine, which is negative sine theta and theta dot. Okay? So looking at this expression, we're going to want to simplify it somehow. So let's look at the left-hand side. We know that c dot is 0, right? That rigid bar c is not going to change its size at all because it's rigid. So we can write c dot is equal to 0. Okay, everything else looks fine except for theta dot. We know theta dot's not going to depend upon time, so that term will be 0 as well. And then, a dot and b dot, those can change because they are with respect to the collar's position. So now we can write 0 is equal to 2a dot, 2b dot minus 2 a dot b cosine theta plus a b dot cosine theta plus 0. Okay. We'll pull that term over to the right, and I will distribute the 2 as well. So we'll have 2 a dot b cosine theta. Want to be careful that we take our time and carry out all of our variables correctly. 2a b dot cosine theta, and now we'll write the other terms, is equal to 2a dot plus 2b dot. Okay. Moving right along, we wanted to solve for b dot, correct? So let's get all of our b dot terms on the left-hand side. we got 2ab dot cosine theta minus 2bb dot, and that's going to be equal to 2a dot b cosine theta plus 2a dot. Oh, excuse me, we got a minus sign in there. There we go, that looks right. Okay, we'll collect our terms. We'll have b dot times 2a cosine theta minus 2b is equal to you know what, we'll actually pull the a dot out as well. A dot times 2a minus 2b cosine theta. And then finally, we'll just divide out. So we'll have a dot times 2a minus 2b cosine theta all over 2a cosine theta minus 2b. All right, great. That was just a lot of bookkeeping, but that's our expression. However, the problem also wanted us to solve if cosine theta, or excuse me, if theta was 120. And so that's pretty simple to solve. So if theta is 120, cosine theta is negative 1/2, right? So we can write b dot is equal to a dot times 2a minus 2b negative 1/2 all over 2a negative 1/2 minus 2b. B dot is equal to a dot 2a plus, right, the 2's are going to cancel, plus b all over negative a minus 2b. And finally, just to clean up a little bit more, I don't like this minus sign in the denominator. I just think it kind of looks weird. So I'll pull that out and I'll put it on the top. So we'll have negative a dot times 2a plus b, and that'll all be over a plus 2b. And there we go. This is our solution. And I'll just to make it more clear, when theta is equal to 120 degrees. Box that guy up, and there we go. So yeah, I hope that problem and working through that was helpful. Just again, you know, working with these problems, it's going to be, sometimes it is going to be a lot of bookkeeping, and you're going to want to get practice in doing this algebraic simplification and just being able to really keep track of your signs and variables as you need to. And so yeah, so I hope this was helpful and hope you stick around for the next video. Thank you.